Hey friends, it is good to be talking to you again. We are still in chapter 3, but we're about to end it. We're going to look at adding and subtracting unlike fractions. So this should be pretty much review, but we're going to talk about it. We're going to throw some negative numbers in there and some other operations so we can, see how well we can do it in this algebraic context. All right, so let's take a look. Our vocabulary today is just one term, and that's unlike fractions, fractions with different denominators. And I don't think I need to give you examples of that. I think you guys know. All right, so our first example, here it is. So we have two pairs of, or two problems, two parts to this problem where we're going to be adding these two fractions together. All right, so you can see that the denominators are unlike, right? They're not the same. And what we have to do is make sure we find a number that 4 and 6 can divide into evenly. So a number for which 4 and 6 are factors. And what we want to do is find the smallest of those, because the larger it is, the more reducing we have to do at the end. So yes, we could multiply 4 times 6, but that doesn't give us our smallest. If we think about the multiplication tables of 4 and 6, we know that 12 is the common denominator that we can use. It's the least common denominator. 4 goes into 12 3 times, and 6 goes into 12 2 times, and that's pretty good. The fact that 4 goes into 12 3 times means that I'm going to multiply the numerator by 3. So check this out. In essence, I multiplied the denominator by 3 to get the 12, multiply the numerator by 3, and this becomes 9. I'm going to do the same thing with the 6, but with the 6, I multiply the denominator by 2 to get 12, so I'm going to multiply the numerator by 2 to get 2. And so now these are the two fractions that I'm working with. I've got common denominator, which is awesome. 9 plus 12 is going to give me 11 over 12. There's no way to reduce that, so my answer is 11/12. Let's look at the next one. So this next example, 7 and 3 can both go into the number 21. In this case, I could have multiplied both of the numbers together. If you notice, these two numbers are prime, and there's something called mutually prime, which means that they have no factors in common. So even if they weren't prime themselves, they could still be mutually prime. I'll give you an example really quick over here. So 4 and let's say 9 are mutually prime because they have no common factors, like the 2 goes into 4 and 3 goes into, well, no common factors aside from 1, sorry. So when you have a situation like that, you just have to multiply those two numbers together. Don't go back in your brain thinking about multiplication tables. You know that if I have 4 and 9 as denominators, I'm just going to have to multiply them together because they are mutually prime. They have nothing in common. That's what mutually prime means. All right, that was just an aside. I'll take that away and back to the lab. Let's go back to what we were doing. All right, so check this out. When I have 7 and 3, they're prime and also mutually prime. So 7 times 3 is 21. And my new numerator, I'll get from recognizing that I multiplied this denominator by 3. So I've got to multiply this numerator by 3. And this is going to be a 15. But watch this. I'm going to make sure and carry that negative along for the ride. Okay? And then here, this guy was multiplied by 7. So if I did it at the denominator, I got to do it at the top. Recognize when I multiply the denominator and numerator by the same number, it's like multiplying by 1, right? Because the same thing over the same thing is the number 1. You feel that? Okay, I hope so. 3 times 7 is going to give me 21. 2 times 7 gives me 14. So now I have negative 15 plus 14 over 21. I'm going to write that down like this. And then finally, I can see that the answer is -1 because we remember how to add negative and positive numbers. All right, let's keep it moving. I spent a long time on that. Let's see this guy over here. So again, we have kind of fractional situation. The common denominator, these guys are not mutually exclusive. 2 goes into mutually prime, 2 goes into 6, and 2 goes into 8. So I'm not going to just multiply them together. There's something else. If you take your time, you'll realize that 24 is a common denominator for both. Since 6 times 4 gives me 24, I'm going to multiply the numerator by 4 and I'm going to get 20. Remember, this whole thing is negative. And since 3 times 8 is going to give me 24, I'm going to multiply the numerator by 3 and I get 3 there. So now I'm adding these two guys up. My denominator is 24. My numerator is going to be -20 plus 3, which we know to be -17, and I'm shutting it down. That's it, my people. All right, let's take a look at this guy. Ooh, Lord have mercy, this is ugly. Well, we got a couple ways of doing it. So we got this mixed number, right? And this mixed number right here, It's all good. I believe that the easiest way to get through this is probably to change this to an improper fraction. You don't have to, but when you get negatives and positives in there, sometimes it's just easier to change it to an improper fraction and then add your improper fraction together. So that's the way I'm going to go with this. So this, I'm going to rewrite this first number as a negative, just rewrite it exactly as it is. And then this guy is going to be negative, now 5 times 4 is 20, plus 3 is 23, negative 23 fourths, okay? So that's the first thing. The next thing I'm going to do is come up with my common denominator, and I'm hoping that you guys recognize that 20 is the common denominator. They both have 2 as a factor, and we can kind of talk about that a little bit later, but I hope you guys are getting where I'm coming from. So if I multiply this guy by 2 and this guy by 2, my new numerator is going to be negative 6. And if I multiply this guy by let's use a color that works. If I multiply this guy by 5 and this guy by 5, my new numerator, I got to do some quick math here, is going to be, let's see, I'm adding, this thing's negative. 5 times 3 is 15. 5 times 2 is 100, so 115. All right, so this is what I have, and now my denominator is just 20. I'm going to add these guys up, and I get a negative, I think 121, if I'm not mistaken, negative 121, and now I can divide 20 into it to get the mixed number answer. If you left it as an improper fraction, like there's no way to reduce this as it is, but we can change it to a mixed number. But if you left it as an improper fraction and I don't expressly tell you to change it into a mixed number, then you're all good. So don't feel like you have to worry about it. But 20 goes into 121 6 times with a remainder of 1, and the answer is negative 6 and 1/20. Not too bad, hopefully not. Let's take a look at this next example. Example 3, subtract fractions and mixed numbers. So it's going to be the same thing. I'm going to change these mixed numbers in each time into improper fractions. I feel like that's the most straightforward way to do this. My common denominator for this guy over here is going to be 8. So I'm going to put an 8 here, subtraction reigns. I didn't have to multiply this by anything. So technically I multiplied the denominator here by 1. So I'm going to multiply the numerator by 1 and get 3, the same thing I started off with. Here I had to multiply this denominator by 2. So I'm going to multiply the numerator by 2 and I get 6. So now what I'm dealing with in this problem is 8 as the denominator and 3 minus 6, which is negative 3. So my answer is negative 3/8. This one over here is going to take a little bit of work, but let's go ahead and change everything into improper fractions. 9 times 5, well, should I? Yeah, I'm going to. Well, okay. Yeah, okay, I'm sorry. I'm overthinking this. So 9 and 3/4. I'm not going to change it to improper fractions yet. Do you see my hesitance? Because those bad boys would be big. 9 times 4 is 36, 37, 38, 39. So I have 39 over 4, and then 21, 22, 23, 23 over 3. And then I'd be multiplying the top. And I'm not sure I want to do that. So here's a little way we can get through this. You can do that, and it will be fine. It will just be a lot of work. Here's what I'm thinking. Let's just deal with the fraction for now. Right? So I have 9 and, what would be the common denominator of these fractions? It will be 12, right? 4 and 3 are mutually prime. They don't have any factors in common, so I'm going to end up multiplying them together to get our common denominator, all right? So I'm using 12. So check this out. What do I multiply 4 by in order to get 12? 3. So if I do it to the bottom, I'm going to do it to the top. What am I going to multiply 3 by to get 12? 4. I'm going to do it to the bottom, do it to the top, and I have that. All right, so now that I'm here, now this tells me what I need to do. So we've had problems like this before where we have a mixed number and we need to make sure that the fractions can be subtracted. In this case, they can. The larger mixed number has a larger fraction, so it's really straightforward. If it didn't, we'd have to do the borrowing thing, or we could change everything into an improper fraction and continue. All right, I'm talking a lot. I know you're tired. So 9 minus 8 is 1, so I have 1/12 for my fraction, and 9 minus 7 is 2. So my answer is 2 and 1/12. Let's look at this one. Ooh, add and subtract mixed numbers. So here we have a computer. Here we have, to set up a computer network in an office, a 100-foot cable is cut and used to connect 3 computers to the server as shown. So we've got some information here, boom, boom, and boom. This is the question. how much cable is left over to connect the third computer. So we know that we started off with 100 feet, and we're going to subtract 19 and 1/8 feet, and we're going to subtract 40 and 3/4 feet to figure out the answer. All right, so this is what we're looking for. This would be the question mark. That should be a question mark and not a 3 chapelitos. Okay, so that would be the question mark. So how will we do this? What makes sense? When I think about this problem, I'm thinking about the fact that if I can add up these guys together, then I'd know the whole amount that has been used. Does that make sense? And then I can subtract that value from 100, because I don't feel like playing around with fractions and fractions and fractions. If I can just join them together, I feel like that would make more sense to me. So I'm looking at this problem as 100 feet minus the sum of 19 and 1/8 plus 40 and 3/4. So I'm going to do what's in the parentheses first. And let's give me some more space. So the 100 is still here. My 100 is still there. And so now I'm adding these guys together. My common denominator would be 8. So I'm going to leave 19 and 1/8 as it is. But this denominator here is going to change my numerator. So I multiply that by 2. I multiply that by 2, right? So I end up with 6/8. When I join these guys together, I get 100 minus 6/8 plus 1/8 is 7/8, and 19 plus 40 is 59, not 50. Let me make that a 9 so nobody complains. And so now I can deal with this. Does that make sense? You see what we did? I hope so. So now I'm going to take that 100, I'm going to subtract here. You guys know that we can use our little borrowing technique, or so we can write this as 99 and 8/8, right? Because 99 plus 1 is 100, and I'm using 8/8 because that's a convenient fraction given my denominator, minus 59 and 7/8. The beautiful thing is that the fractions will be fine, just the larger fraction is with the larger number, and so 8/8 minus 7/8 is 1/8, and then I move over to the larger numbers, or the whole number is 99 minus 59 is, 59 is going to give me 40. So there's 40 and 1/8 feet of cable left to finish off this this computer networking system. And I think that's it. Yay! We've come to the end of our video, and hopefully it wasn't too grueling. I know I did a lot of talking. I know a lot of you already know this stuff, so don't feel bad if you're like, oh my gosh, because I get it. But some of you might have needed the extra, attention to some of this. If you still need more help, let me know. Let's talk about it, because fractions can be somewhat frustrating. I love you guys. Can't wait to see you soon. Take care. Bye-bye.